right, AP Calculus. We are on final exam 1-4 Thursday. This is going to be the key, right, Kaylin? All right, and then we move on to this problem right here. We're trying to find this region. This one is going to be no calculator, so we'll write up here no calc. I can tell because it says problem number 4. Whoa! 1 and 2 are calculator. 3 through 6 are not. Yeah, so we have our two graphs here. Which one is which? Which one is 2x? Which one is x squared?
2x is the one that's going straight up.
Yep.
Like the linear.
2x is linear, that's straight line, and therefore x squared is the nonlinear, the one that's curvy. Cool, cool. All right, let's do part A. Find the area by hand, no calculator, of r. So it's just going to be top minus bottom with the integral. So it's going to be the integral from where to where?
From 0 to 2.
Yes, from 0 to 2. Those are the x coordinates, so x coordinate 2, not 4. And then it's going to be top minus bottom. Top is 2x, bottom is x squared, so 2x minus x squared. All of that dx.
So it's going to be x squared. Well, it's going to be 2x squared over 2.
Yep, the 2's will cancel out. Perfect.
Minus x to the third over 3.
Perfect. Evaluation bar from 0 to 2. When I plug in 0, what do we notice?
They'll cancel out.
Yes, and that means we're only plugging in 2. So it's going to be 4 minus 8 thirds. And 4 can be rewritten as 12 thirds by multiplying the top and bottom by 3. So 12 minus 8 is 4, and the answer here is 4 thirds. If we had units, it would be units squared because this is area. Preguntas. Próximo. B. Something happened to Mr. Sindel. He's broken. He's speaking in Spanish. I did, yeah. That was fun.
Like
and hard.
When they tried to switch them up in
Yeah, my Algebra 2 class loves it when I just do a Spanish lesson. All right, so are we doing squares? Are we revolving? What are we doing for part B?
We're revolving around a circle? Or is it just going to be, wait.
It's kind of neither of those two. So I'm looking at this. So for this solid, each cross-section is perpendicular to the x-axis. So this right here means everything is in terms of x. I'm going to write that down. Everything in terms of x. If it was around the y-axis, that means everything has to be changed in terms of y. We have to say x equals something something y. So luckily it's around the x-axis, which is the easier of the two. We don't have to change these functions. And we're saying the height here, when it pops out into the third dimension, the height is this function. It's not a square. It's not a revolution. The height is a function. All right, let's try it out. So first, I need to draw a cross-section. Whenever you're thinking about solids, always start with a cross-section. My cross-section isn't going to be exactly a rectangle, but I'm going to make it a rectangle. If you want to make this like a sine wave or something to remind yourself that it's not exactly a rectangle, you can. There is my cross-section. I don't know exactly what's happening here. Something with sine wave.
Wait, why'd you add a squiggly line?
Because the height is going to be a sine wave. I guess if I was being very professional about it, I guess the height would probably look more like this. It'd be like one giant one instead of random squiggles. But
that would be on just the top or the top and the bottom?
So just the top. So the base shape doesn't change. The base is always flat, and then it's saying the height into the third dimension coming out is this function of sine.
I was saying the area is that.
I was saying the area?
The section has the area.
Yeah, so the cross-section means it's popping out into the third dimension. If I slice up that piece of bread in the third dimension, imagine a piece of bread that just popped out in the third dimension. I have a graph. Maybe I should do this digitally.
So wouldn't the edges be
I
the
think-
squiggly line then, not the top?
And isn't A the only function that matters for this one because the area of the cross sections is already given? So to find the volume, you need to.
Just do the bounds, right?
Yeah.
Yes, you're correct. But I just want to make sure that everyone can visualize what's happening. So I have an area. The area let's even come back up here. This is the area. It's popping out into the third dimension, and with each slice of bread, each slice of this volume, that slice looks like, let me try my best approximation, that slice is some weird sine wave. But it doesn't matter what it looks like, as Ben said, because the hardest part about finding this is finding the area, but they gave us a formula for the area. They're saying, hey, there's the area right here.
It's parallel to the other two, right? So the two ones? The height is basically parallel to.
I don't know what you mean by parallel. The cross sections look like this. The cross sections are still perpendicular to the x-axis. So the way that I slice it up. So each of these slices has some height that's determined by the function sine of pi over 2x. Let's just kind of move on. Assume that, okay, we know we're doing area. We're going to take the integral. We know that this area right here is sine of pi over 2x. So this a is equal to sine of pi over 2x. We don't even need to figure out that area. It tells us what the area is. Sometimes it'll just say the height is this and this, and you have to do height times base and do some extra stuff. This one is even nicer. You just have to take the integral. What are our bounds going to be?
0 to 2.
Is it 0 to 2 or 0 to 4?
0 to 2.
Explain why.
4.
It is 0 to 2. Someone tell me why.
Because 2 is an x value for the y value.
Yep, and we're doing everything in terms of x because it says the x-axis up here. So if it said the y-axis, then we would do bounds from y, 0 to 4. All right, so 0 to 2 of this function of a. So it's going to be sine of pi over 2 x dx. Oh. That isn't going to work, is it?
Because it's an integral. It's like weird.
Because we're let me back up here. Don't write, if you can erase the dx, please do so. So we're correct in thinking that this is the area. But what is volume? What is the definition of volume?
Based on height? No. Area times height.
Isn't it pi r? No, it's height. Length times height.
It's base area times height, and they gave us just area here. We only have 2 dimensions here. We need 3 dimensions, don't we? We're somehow...
dx is the third dimension. It's the
No,
thickness
because then we only have 2 dimensions.
of each cross section.
Because this is.
So Ben, you're right in thinking that this is dx and this cross-section dx, but is there anything restraining us to these 2 shapes, 2x and x squared?
No, we need to find the bottom.
I don't think you need to though, because it's still,
Or is it contained within the area?
it's, even if it's not this, no, it is going to be the same shape because the height can change to accommodate the area. Like that. I don't think it really matters because they just give us the area.
Okay, I'll have to look this one back up, but I understand the logic of that is the volume because we have all 3 dimensions, but I'm just confused as to how it should be somehow confined to this base shape, and I don't see how that is taking that into account.
Maybe
Wait,
it's
so
just
it
in
is.
the area formula.
It is like the base of the cross section, or the base of the solid, is going to be r, and then what affects the area of each cross section is going to be the height.
So you're saying that pictorially what's happening is that this bottom is really r, but since we're taking thin slices dx, then we're automatically taking in r.
Yeah.
So we have to multiply them together.
No, he's saying that dx accounts for the fact that we're doing r.
I think so.
And I think that's as close as we're going to get because otherwise I don't see a way to solve this. All right. I feel bad that I don't know this problem very well.
Let's just try it and see if it gets. Do you have a key?
I can look up a key. I don't know where this problem is pulled from, but it's clearly an AP problem. Yeah, let's go ahead and do it. So this is going to now be antiderivative of sine of pi of x. What am I going to have to use? Why am I going to be using taxman, someone aside from Ben?
Because because x isn't multiplied by 1. Or it's hard to
That's
explain.
one way, but what's the official way?
Yeah.
Say it one more time.
U prime isn't 1.
Yeah. Dinner is not 1. U prime is not 1. Okay, so U is pi over 2x. Taxman is out front 1. U prime is going to be pi over 2. When I do 1 divided by pi over 2, that's the same thing as taking the reciprocal of pi over 2, which is 2 over pi. And if you don't believe me, this is really a keep it, change it, flip it rule. So it's 1 divided by 1, keep it, change it to a multiply problem, flip it, which is the reciprocal pi, or 2 over pi. 1 times 2 over pi is 2 over pi. All right, so using that taxman, I'm now going to say this is going to be, there we go, 2 over pi. The integral between 0 and 2 of sine of pi over 2x, all of that dx. My parenthesis there wasn't quite where I wanted. And now when I take the antiderivative of sine is that negative or positive cosine?
Negative cosine.
Yes. Why negative cosine?
Because it's the antiderivative of sine, which is change.
There it is. Negative 2 over pi cosine of pi over 2x, evaluation bar between 0 and 2. All right, so when I do that, how much room do we need for part C? Oh, part C is 1 line. Nice. Okay, so when we do that, I have negative 2 over pi out front. I'm not going to deal with him. I'm going to work with the evaluation with the cosine. So let's plug in 2 first. 2 pi over 2 is just cosine of pi. Cosine of pi, what is that?
Cosine of pi is 0?
Not 0?
Negative 1.
Negative 1, yep. So if I'm looking at pi, I'm going to erase this in a sec, but pi is over here.
Oh, pi is over there, so yes, it's negative 1.
And then the x coordinate for cosine, and that would be negative 1. So I have negative 1 minus whatever I do for 0. When I plug in 0, that's cosine of 0. Cosine of 0 is?
1.
1, yep. So 1 minus 1 is negative 2. Negative 2 times negative 2 is 4. This is 4 over pi.
Where did you get the other one from?
This second one?
Yeah.
So I plugged in 0, cosine of 0, right?
Oh, okay. So
And then-
you just plugged, yeah, okay. I get it.
And then just making sure that we're all on the same page. 0 is right there. The x coordinate there would be 1. All right, and we will check that to see if we got the right answer. Hopefully I'm not leading you astray. If we went astray, it was with somehow our visualization of that problem. But I think Ben has it right. It should be, this should account for our, hopefully. I'm just not confident in my abilities. I don't know what's going on. Part C. So we need to write an equation where we're doing squares perpendicular to the y-axis. Uh-oh, y-axis. Now everything's going to be in terms of,
Wait, what did you get on B?
or sorry, b I got 4 over pi.
I got 2 over pi plus 2. So I think the first. Oh, you did it a little differently because it was like the 2 pi was up front.
Okay. You want me to do it your way and see if I get the same answer? And I can erase it if I need
should
it.
be the same.
So you probably did negative 2 over pi, and then that times negative 1, right? So that times negative 1, and then I'm going to subtract the next thing. I have negative 2 over pi, so plus, I guess I can do a double negative to show I'm doing 2 over pi like this. Is that what you did?
Kind of. Cosine of 0 is 1.
Yep. So this thing times 1, and then double negatives kissed, they become positive.
Oh, wait, I forgot to. That's why.
Okay.
I forgot to divide the last one. Second term by pi. I had it all as like one fraction.
Ah, yeah, that makes sense. Cool, cool. Then we're on to part C. So we're doing things in terms of the y-axis. That means everything is in terms of y. Everything in terms of y. That was a bad y. Y. And they're going to be squares. So that means I need to rewrite both of our equations here in terms of y. I need to say x equals something. I'm isolating for x. So the first one is going to be pretty easy, right? The first equation is going to be x equals
2 over y?
Y over 2.
Y over 2?
there you go, y over 2, yes. And then the next equation, I think you can probably just get it right now. X is equal to
Square root of 1.
Careful.
Positive or negative?
Yeah, plus or minus square root of y. All right, so now we have our equations in terms of x, and then
Wait.
from,
How'd you guys get square root of y?
so I'm looking at this guy. To get x by itself, I take the square root of both sides, and I get x by itself is equal to plus or minus y.
Oh, where did the y over 2 come from?
Y over 2 was this one, so I divide both sides by 2, and I get y over 2 is equal to x. All I'm doing here is I'm solving this one for x, solving this one for x. So I'm undoing whatever happened to x to get x equals something. I need to have an equation where everything is written in terms of y. X equals something, 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 y.
Oh, so, okay, never mind.
Perfect. All right. Now that we've written plus or minus y, which one is it and why? Because we're still only looking at this area, which is only what? Is it only positive y, only negative y? So looking at this shape, do I have positive or negative y values? Only positive y values. So I just want to make sure that everyone was thinking it is actually square root of y because of the domain restriction from the original problem. Even though the inverse is plus or minus y, you come back and look at your domain and be like, okay, everything had only positive values of y, so I only need to take the positive value of square root of y. All right, so from there, I now need to do square cross sections. Again, looking at a cross section of a square. That was a horrible square. I have technology and I could do a perfect square, but there's what you should be drawing, where this and this are congruent. The side lengths are congruent. I now need to figure out what the length of everything is. So I need to do one minus the other, and it doesn't matter which one goes first because I'm going to square it, so it's going to be positive, right? So I mean, if you want to do top minus bottom, it should be, if you're looking in this direction where this is top, I guess, that means you're going to do the x squared term first, but again, it doesn't matter. So I'm going to do square root of y, that's a bad y, square root of y minus y over 2. That's that length, and this length is also the square root of y minus y over 2, which means the area is that thing squared. So here we go, our integral. What are our bounds for our integral?
Would it be
It is 0 to 4, yeah. So it gave us our bounds. It goes from 0, and it gave us 4. So everything's in terms of y. Bounds are in terms of y. And what's going to be the integrand, the inside part?
square root of y minus y over 2 to the power of 2?
All that to the power of 2 and
dy.
dy. Yeah, everything is in y. The bounds are in y, the equation's in y, dy, integral with y. Done.
Done?
Yep, it just says write but do not evaluate. And there's our final answer.
Why couldn't they say right but do not evaluate? Part B?
They need to give points somehow, Rochelle. Got to make you do work.
Not my point.
All right, on to number 22, multiple choice. Unless there are questions on the free response. All right, graph of f prime. The derivative of f is shown above. This is f prime. If f of 0 equals 5, so that is our start. F of 0 of anything, you should be thinking of start. Then what is f of 1? What is the definition of our end? End is equal to
Start
start
plus change.
plus change. And change is approximated by the integral, right?
Oh, yes.
Yep. All right, so end is going to be start, which is what?
5.
Plus what?
The integral from 0.
0 to 1 of
F prime of x.
prime of x. There it is, dx. And the integral graphically is just the area beneath the curve, right? So we need to find the area beneath the curve of this shape.
So it's 3.
So it's 8.
You both have it correct. You're talking about different things. The integral is approximated by 3. And the answer here is 5 plus 3, which is 8. I don't know why I'm boxing it, because the answer is right there. Questions about 22? On to 23, or 24, I guess.
Wait, where's 33?
So the reason that I skip questions is because those aren't necessary to pass the AP test. If you want to learn them, then come in after school or at lunch and talk to me about them. So 24, we have that function. We're looking for the equation of a line tangent. You're immediately thinking.
It's the answer C.
No. I know that Ben, Claire, and Miss Kirkby have that poster up there with our 7 mindsets, but don't do
is
that.
one of our 7 mindsets.
It's the 8th mindset.
It's just this question is always like seen, so I'm guessing C.
Okay, it might be C.
Wait, is it true that you're more likely to get it right, to get a high percentage right, if you just guess like C, 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 than if you guess random numbers?
Yes.
I mean, so you're asking, are the multiple choice questions equally distributed?
Yeah.
Is it standardized?
Well, no.
I believe the AP test is not standardized.
So if you,
It might be. I should look it
so
up.
is it better to just, if you have like a ton, would it be better to guess C, 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 or do like random numbers like A, B, A, C, A, B?
Probably
So I believe if you you should have a roughly equal chance of both, even though it's not standardized. If it was standardized, then you should have the exact same probability. If you randomly guess versus guessing all C. Yeah, anyway, this one, y minus the y coordinate, so y minus y1 is equal to the slope, or f prime, of that coordinate times x minus that x1 that we're looking for. All right, x1 it gave us. x1 is -1. The y coordinate, this is y of -1. What is y of -1? Well, we plug it in. So, -1 cubed.
That's -1.
-1 times 4.
4.
I'll write it down. And then -1 times -5.
Positive 5.
Positive 5, and then plus 3. So 5 plus 3 is 8. 8 minus 4 is 4.
Wait. No.
yes.
Yeah, sorry.
4. This is what I was doing here was f of -1 is equal to those things. And then finally I need to find, what is this thing going to be right here?
It is going to be the slope.
The slope,
Prime.
or f prime of -1. All right. F prime, we'll do that first. So f prime of x,
12 x to the power of 2 minus 5.
therefore f prime of -1 is
7.
7. All right, so I should have a slope of 7, so it's automatically not D or E. And then I need to double negative kiss, so x plus 1 plus 4 plus 5. Oh, I forgot to distribute the 7. 7 times 1 is 7. 7 plus 4. Rochelle had it. Let's see.
I told you, I've been seeing this a lot of times, so I know it's C.
I mean, yeah, you've probably seen this question now like 5 times because I keep putting it on the test or pre-test or everything. But that's not going to happen on the actual AP test. They don't reuse the same exact questions. Or if they do, they're definitely going to switch the letters. All right, number 25.
C. I'm just kidding.
Maybe it is.
I mean, you have a 1 in 5 chance. And on the actual AP test, you'll have a 25% chance because it's only A, B, C, or D.
That can't possibly be right.
I see a problem with the way that you guess. Please stop, guys. You're killing me. Okay, at what time is the particle at rest? What does that mean? Am I talking about position, velocity, or acceleration?
Position.
Oh, no to Rochelle. Yes, there. Particle at rest. What do we know about velocity?
Velocity equals 0?
There it is. That's the thing we're noticing. The velocity must be 0 for the particle is at rest. So we're given position. How do I get from position to velocity?
Derivative, right?
Yep, velocity is equal to the derivative of position. So what is the derivative of position?
It's going to be 6t to the power 2 minus 42t plus 72.
If I make my pluses really tiny, then they can't be confused for t's. Pro tip.
You can confuse them for multiplication symbols.
Well, what if you just use
Touche.
Oh yeah.
Gotta curve the
If
t's,
you
make
use
the
the
pluses.
dot, then maybe it's a little more.
All right, now I need to find when this is equal to 0. So now I'm going to say that is going to be set equal to 0. What is the GCF of all of these things?
Wait, what? Oh.
24.
No.
6.
Common factor, Ben.
0.
You know what's even funnier than 24?
25
25.
minus 7t. Is that a curved t enough?
None of you guys got it. This was fun.
Plus 12.
You know the story behind that joke is because, like, there's like some, maybe it was like Cartoon Network is on channel 24, or was, and then Nickelodeon, which is where SpongeBob plays on most of the time, is on 25. So 25 is funnier than 24.
I get it. So that's why they did it?
Yeah.
Oh, that's pretty savage. What do you want?
Yeah.
All right. I'm going to divide both sides by 6. The 6 goes away. Okay, now I need a factor. What times what?
Oh, it would be -3 and -4.
T minus 3, t minus 4. Therefore, my answers are 3 and 4. Looks like I'm on E.
Wait, B?
E as in echo.
Oh, I said B. I'm like, wait a minute.
And my final thing for the video will be number 26. What is the slope of the line tangent to the curve? Again, this one is not looking for the line tangent to the curve. It's looking for the slope of the line tangent to the curve. Slope here means I'm doing what?
Is it Y prime?
I'm looking for y prime. Y prime. Okay, so we need to find y prime. Oh boy, we got all this stuff. So you have one of two strategies when you have a mixture of x's and y's, especially for this one, which is multiplying the x's and y's, which is going to be a product rule. You can either rewrite everything right now or just take the derivative and rewrite it later. I'm just going to be lazy and just take the derivative now. Get some practice in. So derivative of 3y squared with respect to x, 6y,
Y prime.
y prime, minus,
-4x.
good, x prime, which is 1, equals,
Just -2y to y prime.
so it's going to be product rule. What are you going to say is 1? Are you going to say that -2x is 1 and then y is 2?
Oh, -2x is 1 and y is 2.
Okay, so that's how I will put it in the notes as well. This is going to be 1 and this is going to be 2. So product rule, 1d2, 2d1. So I'm going to say 1 is -2x, d2 is
Y prime.
y prime, plus 2d1, so 2 is y, and what's d1?
2.
Careful,
Oh, -2.
-2. Yeah, you could have left that -2 factored out and did it later, but we just did it at the same time. All right, we're trying to find y prime at the point 3, 2. Let's plug that in right away. So 3 is going to go for every x, that's a 3, that's a 3, and then 2 for every y, that's a 2, that's a 2. And then we're going to solve for y prime. Here we go. I have 12 y prime is equal, or sorry, not equal to, minus 12 is equal to -6 y prime minus 4. So far so good. I haven't made a mistake yet. Yay. All right. I'm going to choose the left-hand side for my y primes. I'm going to add a 6y prime, and I'm going to get an 18 y prime. On the right-hand side, I'm going to add 12 to both sides, and I'm going to get plus 8, so positive 8. And then finally, divide both sides by 18. I'm going to get y prime is equal to 8 over 18, which is 4 over 9. 4 over 9. Yay! We got an answer. B. Preguntas? No questions? All right. Continue working by yourselves, in groups, whatever you want. I'm going to try to actually get the answer key done today and finish yesterday's answer key. Sorry about that.